doing something on it. So you are dealing with the application layer. But how this data will be forwarded to the destination? The data must get the port number, the data must get the IP address, the data must get the MAC address, and then it must be converted to 0101, and then from 0101 to digital signal, then to analog signal, and then forwarded through the cable. Because the cable only understand the pulses, the electrical pulses only. If there is pulse, electrical pulse means 1. If there is no electrical, means 0. So 1001, 1001. This is the only way they are sending the data to the destination. So how the data, when you type something, will be converted to, for example, 0101 is all will be done by the computer in different layers. So that's why we need the layers. Application layers make the hardware software of the lower layer transparent to the sensor network management applications. We have a different protocols over there like SMP, sensor management protocol. We have task assignment and data advertisement protocol. We are not going to go through the details now, maybe later if we have time. Sensor query and data dissemination protocol, or SQDDP. In the transport layer, the layer is especially needed when the system is planned to be accessed through the internet. It will give you the end-to-end delivery. It will give you the reliability. This is provided by this layer. It will check the congestion control, whether the link is congested or not, or can I send the data now or not. This kind of control will be done at the transport layer. So the upper layer is application. Then you go to the transport. From transport, you go to the network. Look at this picture again. Application to transport, transport to the network, network to the data link to the physical. When you type an email in your computer, basically you are in application layer. Once you click, then the data will go to the transport layer. From transport, it will go to the network. From network, will go to the data link. From data link, will go to the physical, and the physical will convert it to 00, and the electrical pulses through the cable will send it to the destination. The same thing happening at the sensor network, but in different way. Of course, the devices and the capability that we have in our devices in the conventional network or normal network, we do not have in the sensor network. So the protocol also we are using are different protocol as well. But the layers are same. So we have the application, transport, network, data link, and physical layer. So we discussed about the applications, transport layer. Network layer is a power efficiency is always an important consideration here. The sensor network are mostly data centric. Data centric meaning that in wireless sensor network, the data are permanent, right? But the applications come and go. You can have different application at the application layer. But what is permanent is collecting the data from the environment. So that's why we call it data centric. Data aggregation is useful only when it does not hinder the collaborative effort of the sensor. What is the data aggregation that we will discuss in separate lecture as well? Is gathering the data and presenting in a summarized format. When your sensor nodes collect the data from the environment, so it has to put it in such a way that should be understood by the other devices. So before sending the data, it will present it in a summarized format and will forward to the sink, for example. We call it data aggregation. And an ideal sensor network has an attribute-based addressing and location awareness. So what is a attribute-based addressing? For example, the node can sense 350, for example, degrees and above, we want to find them, find their addresses, find their location. So that's why we call it the sensor node. Should have the attribute-based addressing and location awareness. Right? Look at the area. Something happening in the uh, event area inside our wireless sensor network. So these few nodes here, or sensor nodes, they want to send the data to the sink. Can you see that? But they are a bit far away from relay and also the sink or controller. So the data must be forwarded to the other nodes, and the other nodes must route or forward the data to the sink. The problem here, how to efficiently route the data. How to send the data from the sensor to the sink, and also the queries and control packet from the sink to the sensor node. Sometimes we need to send the control packet, or we want to tell the node to be off, to be on, to be void, to do these things. A few things only we will see also the number of tasks later. So the queries and the control packet to send from sink to the node, or the data from node that collected the data must be forwarded to the sink. So how basically we can do that? Routing is a main issue in wireless sensor network. Let's say there is a node here that something happened and the node sends some data. So the phenomenon being sensed. The data aggregation take place in this sensing node. So when the node sends the data, aggregation means put it in a summarized format. Whatever you sense may be not good to be forwarded to the sink. So you have to put it, let's say you want to uh, prepare a presentation. I ask you to discuss about the wireless sensor network on, I'll give you a topic to search and research. So how you are going to explain it to me or to your classmate? So you will put it and summarize it in a PPT format, PowerPoint, and then you will present it, right? So basically this one is a data aggregation example. So after the data aggregation, the node itself is going to send the data to sink. So we use a multi-hop routing. Multi-hop routing meaning that multi-hop, multi-node, meaning that from one node to another, to another, to another, until it reaches to the sink. So the multi-hop routing is common due to limited transmission range. So the issue about the routing, we should consider the low node mobility, power aware, irregular topology, meaning that sometimes your sensor network moving in your environment. MAC aware, we discuss about the media access control protocol later. Limited buffer space, because the node that want to transmit the data must receive, must buffer the data and forward it. So that one is also limited, the space. So let's look at the communication architecture of the sensor network. For example, we have a sink here, we have a node A, then node B, then node C, we have D, we have E, F, and T. So something happening here in T. We want to see the path between sink and T. Route 1 is from sink to A to B to T. So we have sink A, B, T. This is one route. Route number 2 is sink A, B, C, then T. Route 3 is sink D, T. Another route, which is route number 4, is sink E, F, T. So each route, so here we have 4 possible routes from sink to T. The first route is a minimum energy route, for example, and minimum longest edge route. Number 2 is, for example, the maximum available power route. We have the maximum available power in these nodes, route number 2. Route number 3 is a minimum hop route, meaning that the less number of devices between. And also the maximum minimum available power, PA node route. So we have a different kind of route here. And each route, as you can see, has a, let's say the first route got alpha is, total alpha is equal to 3. Number 2 is equal to 6. Number 4, alpha means relative influence of cumulative phenomena on the path, meaning that the greater alpha is, the bigger the probability that the path will be traveled again. So if number 6, meaning that the probability is much more higher than number 4, that this path will be used again. So route number 2, which is A, B, C, T, the alpha is equal to 6. E, F, T also is 6, for example. So we discussed about the data aggregation. Data coming from multiple sensor nodes are aggregated, meaning that they will be summarized in a good manner or summarized format, presenting in summarized format. If they have about the same attribute of the phenomenon being sensed, so they will summarize and the data will be summarized. That one we call it data aggregation. About the data link layer, if you remember the 5 layers of the architecture, the first one was the physical layer. The second one is a MAC data link layer or MAC layer. The third one is a network. The fourth one is a transport, and finally is application. So we discussed about the application layer protocol. We discussed about the transport. We see the network. Now we are at the data link layer. The data link layer is responsible because data link is connected to the physical. Connecting to the physical, meaning that we have to check the media access as well. Who can have access to the media now? So the media access protocol reside in this layer. Creation of the network infrastructure, fairly and efficiently share the communication resources between the sensor node, power saving mode of the operation, and so on. Another one is the error control. So at this layer, we will check whether the packet that we are sending and receiving are corrected or not. Is there any happening for them or not? An automatic repeat request, that is one of the messages will be sent by this layer to communicate with the other nodes. Reliable point to point, so to make sure that this, for example, node is connected to another one. And the reliability is there. So we can discuss about the reliability once I want to explain about the layer in details later. And point to multi-point, we have point-to-point communication, we have point-to-multi-point. It's something like a unicast, meaning that from one node to another one, or from one node to many, something like broadcast. So that will be done by the data link layer or MAC layer. And the lower layer or the first layer, we call it the physical layer, is responsible for the frequency selection, frequency generation, signal detection, modulation, data encryption, and in fact, to convert the data to 010101. We can have an open research issue here, like modulation schemes, strategies to overcome the signal propagation effect, hardware design, and so on. So as you can see, we are connecting to the hardware. That one we call it physical layer. All right, we can stop here, guys.